All right, hopefully this will be short. This is also hopefully the last in this series of issues because I'm getting burned out on it. Hopefully if you watched the other 3 or 4 or whatever it was, 3 of them I think. And what I want to do is offer a possible solution just from all the stuff I've been trying to figure out. And at the top here, you can see that we have a couple of different kinds of lenses that I've talked about before. This one is kind of the dome-shaped lens. It's a hemispherical lens. It is a converging lens because when light comes from the right side here, the change in density, light wants to go to the thickest part of the lens. It will bend the light toward the center, and this is the focal point. So that's one problem with the dome sky model. It doesn't bend the light the right way. As you can remember from the previous ones, in the northern hemisphere, the sun's path bends toward the center at its zenith, toward the south, I should say. And the opposite is true in the southern hemisphere. The sun's path at its zenith bends toward the equator, which is bending north. So you have 2 different angles, and it's bending toward the center. This one bends away from the center. You can see those angles. So that one doesn't work. The dome, if this is the flat Earth and we're looking up, dome by itself does not work. Okay. Now this is a double, I want to scroll up to say double concave lens. It's thinner in the center, and light goes to the thickest part, so it wants to go out toward the edges. So if the light is coming from the right here, it's going to hit this change of density and splay out. And if you're sitting on the Earth over here, on the surface, any model, this is the sun path. This is what we observe. Each of the extremities is bending toward the center. That's what we see. So we need this kind of a lensing effect between the sun and the Earth in order for anything to make sense, okay? So now, this is one possible sphere Earth model. It doesn't matter whether it's the standard heliocentric or this mainstream standard geocentric, where everything is still a round ball, but in helio, of course, the Earth spins on its axis and orbits around the sun at an angle. And in geocentrism, the Earth does not rotate, but the sun goes around it, okay? In either case, it doesn't matter which it is. It's all a matter of, and as I've said before, even in the heliocentric model, if you're viewing it from Earth's surface perspective, and don't get confused with the word perspective, because we're not talking about slanted lines going off in the distance right now. We're talking about viewpoint. And in both heliocentric and geocentric ball Earth models, you will have the same view of the sun from the Earth's surface. Okay? Now, the only way to make those 2 models work is where you have this double convex or concave lens between them somehow. Okay, there's that shape. This is what you need between the sun and the Earth in order to get these angles that we observe the sun's path on a given day. Not season, but a day. It starts in the east, at any latitude, starts in the east, goes to its zenith and sets in the west. Well, if you're in this hemisphere, it points south. If you're in this hemisphere, it points north. They pinch together toward the center. You only get that all around the Earth at any given moment during a daily path of the sun around the Earth if you have a double concave lens effect between them. You can get that by each body, the Earth over here, the sun over here, having kind of something like a bubble around it. And I don't mean a literal bubble. I mean something bubble-shaped that has lensing properties. That is to say, a difference in density from things outside of it. And this could either be optical, as in water or some other prism-inducing medium, or magnetism. A magnetic field surrounding each body or some kind of optical field surrounding each body would have the same effect. it would lens the light in this manner that we observe at any point along the sun's path around the Earth. So you have to have this kind of lens shape. That can be achieved by putting a round spherical medium of some sort, magnetic or optical or whatever, to cause difference in density so that the light will bend in this way when it comes from the sun to the Earth. Okay, now that takes care of any ball model. Possible flat Earth models. On the left, we have round disk. Why I didn't remember to center that, I don't know. I will fix that. Here we see the sun going around inside this donut. Okay, and the Earth, flat disk. It's hard to depict here, but it's a flat disk inside of a donut. Why the donuts? That's the equivalent of this bubble, okay? Only it's going around the flat disk. The sun is on the top here. So this ball sun is going around, but at every point, it's got this curved lens shape just like here. And the same for the Earth, the opposite curve. And it goes all the way around in the circle. And it causes the light to bend toward the center. From the sun will bend out, okay? It'll be straight down here, matching up these little bands here, and it will splay out according to the outer surface of the donut, okay? As it moves around over the flat disk, because of each of these outer lensing layers, I guess you could call it, or coverings, whether it's optical or magnetic, you will get the sun angles that we see. So even in the flat Earth, if the center is north and the outside is south, doesn't matter which you call it, you will get at the equator, halfway between them, you will get straight up and down sun path going like this. On the southern hemisphere, the outer one, you will have an arc as if you have, like the Golden Archers kind of half arc bending toward north. And on the inner side, you have bending toward south. This shape would take care of a day's rotation of the sun on a flat disk Earth. For a flat square or rectangular Earth, the blue box here, pretty much the same issue. The sun is coming straight towards you, okay? This is north, this is south, this is the equator, and the sun is going east to west. So you're west facing east here. The sun is going to come toward you. As it moves along its path, we again have these angles that match up to observation. So I think that this kind of idea works with any Earth shape, any model, geocentric, heliocentric, or flat. Of course, all flat models are geocentric, but they have a flat Earth. But regardless of the shape of the Earth, you must have between the Earth, or the sun and the Earth, sun, Earth, you must have a double concave lens. And the only way I can think of to achieve that with spherical Earth, either helio or geocentric, each body is surrounded by a magnetic or optical ball, so that whichever moves around the other, you're going to get this kind of observation on the surface of the Earth at any time of the day, any latitude. This is what you're going to see, okay? Same thing with these flat Earth models. The disk can be achieved by this kind of a field around the sun, this kind of field around the flat disk. And if you have a flat square or rectangle, the sun coming towards you here, going east to west, the sun still is a ball. Observation tells me it looks like a ball, even though it's hard to tell when there's no spots. When there are spots, you can see the way they move. When they move out of view, they look like they're going around the edge of a ball. And if you check, with your filter, of course, it's brighter in the middle. So the sun appears to be a ball in every case. But sun moving over a flat square or a rectangle Earth coming towards you would still the rays would still bend out like this according to latitude if the sun has the bubble of magnetic or optical quality, as opposed to the opposite bend of whatever's on the Earth. So this would be more like instead of a ball in this case around the Earth of this lensing part, it would be more like a tube. Okay, a half tube, a half circle matching the length of the Earth. If it had this shape, you would get what we observe on the ground. And I think this is what we have to do to account for observations of the path of the sun going, if it's rising and setting east to west, and yet its zenith is not directly overhead, bent one way or the other. The only way I can think of to make that work in everybody's model is to have this kind of lensing effect between them. And the way to do that in this one is to have two opposing, arcs. And the same with this one. And those arcs are achieved by this donut shape around, and also by a bubble shape, I guess you could call it, around each of these spheres. So I think this works in anybody's model, no matter what shape you have for a flat Earth. You either have this, one way or another, between the Earth and the sun, you have two opposing arcs of different densities. I'm not saying here that there's an actual lens-shaped thing between these. I'm saying that these two shapes in opposition form that kind of a lens. Same thing here. I didn't depict the lens shape here. It's been a little difficult to do, but this sun is going around, and this donut Earth-shaped disc is suspended inside this donut. Same shape. Everywhere at every slice, you have the same shape as this looking edge on, and the same here. I think it works in all of them. And once again, here is a real live light experiment with a real lens shining 3 directed beams. They splay out like that. That's what you have to have in order to explain sun movement over one given day. This dome by itself doesn't do it. Okay? By itself, it does not account for the sun's motion. So you can't just have a flat Earth, tipped on its side here. This is the flat Earth with a dome over it. By itself does not work. The sun also has to have an opposite arc of lensing material around it, which is what I'm displaying here and here. So I think this is a possible solution for sun observation over a given day at different latitudes, different Earth shapes. It works for all of them. That's all I can figure out. Yeah, looking at the chat, I do think that the toroidal one, actually the one on the bottom right with the square or rectangle, I think is the model they're promoting. And all they would need to make it work is this kind of lensing effect. So the sun has to be a ball with a field around it of some sort that causes the lensing effect, and the Earth has to have a half dome shape over it along the length of the square or rectangle. So it works for that shape flat Earth. It works for the one on the left with a disc flat Earth. And it works for both heliocentric and geocentric when each of the, let me scroll to where I am here. Helio and geocentric both have this issue. They have to have these. Now, I still say from my earlier videos that the angle of the sun that they use in the heliocentric model going around the Earth, or the Earth going around the sun, does not explain terminator lines. It's their way of coping with seasons, but terminator lines don't match, and it just, you have to have lensing effect between them. And for flat Earth models, like I said, we've got these two possibilities depending on what the actual flat shape is. As long as it's flat on the surface where we live, This is what you have to have. And let me see if I can find something I drew the other day that has the four corners. I think I mentioned that in the other video, but let me bring that up just in case, because I don't honestly remember. So let me stop screen sharing that and go get this. I'm pretty sure I did mention this the other day. I don't know if I had this drawing, but this is how, two ways actually you can have four corners of the earth and the circle of the earth. So we've got the circle one way or another. The corners have to be inside, because the Bible says that people will be drawn from the four corners of the earth. If you mean extremities, which, as I explained yesterday, yeah, because I got trolled hard for that, but the extremities is the meaning of the ancient Greek and ancient Hebrew. Both have the same semantic range. Extremities, corners, flaps, all the same range of meanings. And if you have just, if you want to strictly stick to just extremities or corners, this is what I think you would have to match it with the circle. But here again, even if it means these outer corners, it's referring to the fact that there are four directions on the earth, because the earth is a circle according to the Bible, and these corners represent the four quadrants of a circle, and quadrant is within its usage in context in ancient times. You can also get the same thing by putting the four corners as internal corners. That is to say, where the four quadrants meet. And you still have four corners, four right angles, and these represent the four quadrants of the earth. This is perfectly biblical, it's geometrical, and you still reference the way the Bible is referencing it when it means the four corners of the earth and taking people from them. It's everywhere on the earth's face. Okay, so this is not incompatible whatsoever with the Bible, and it satisfies everybody's so-called contradictions, because, as with a lot of other things that I've studied on the Bible, where different accounts seem to contradict, on further study and research, you find that they don't. It's just that people weren't visualizing what's going on. And so it is with corners and a circle earth. So at any rate, whether you want the earth to be totally square, and let me go back to my first model in case anybody shows up late. Let me go get my drawing. Here we are. So in either case, flat model, disc, square or rectangle, if you have this on the disc earth, both the earth and the sun are surrounded by a torus, which bends the light the way it must bend for observation, and this is what a double concave lens does. Okay, it produces that effect, and I placed a faint image of that kind of shape here. Sun comes from here, goes to here. If we had two ball items for, bodies for the sun and the earth, it works there. So, which I said is both helio and geocentric models, or both flat earth models. Not to say that some have a diamond-shaped earth or whatever it is. No matter what shape the flat earth is, it has to have this kind of lensing between the sun and the earth, or you won't get observations at every point during the day. Every hour of the day, you have to be able to have the sun doing this. And the only way with the sun moving over the earth is to have these kinds of shapes. I don't see any other solution. I really don't. So, sorry for those who just came. I'm just about to shut down. This is the last, I hope, I'm really not planning to do any more of this series on sun speculation and flat earth, because I spent the first three illustrating the problems with current models, especially the heliocentric model, why a lot of things don't make sense in their own model that don't add up. And in, I think, the one before this, in the comments, and I think I added to the description, some links that show the contradictions in the heliocentric model itself. Without any other model proposed, it contradicts itself. This one, my purpose was to show a possible solution. What has to happen in order to match observations of the sun as it moves throughout the course of a day on every point at Earth at the same time? It almost seemed impossible until I looked at, as I said, I looked at these lenses, and this double concave is the one that works. It splays out the light from the center. So northern hemisphere, it bends down as the sun goes through the day. Southern, it bends up. Equator, it doesn't bend. It just goes straight east and west. And no matter where the light goes, as long as this lens is between it and the Earth, it works. I can't think of any other way to make it work throughout the course of a day at every latitude on Earth at the same time. I can't think of any other way to do it. There may be. It may be more complex, but I prefer the simplest possible solutions, the Occam's razor solutions. And that is, one more time, if the Earth is a ball and the sun is a ball, they both have to be surrounded by another ball of a lensing material, whether optical or magnetic or whatever it is, that creates this lens shape so that the light from the sun does that. And with flat Earth, we always have a stationary Earth and a moving sun. If it's a round disk, it has to go. We have two toroids that winds up creating that same kind of double concave shape between them. Everywhere it goes, on around its path, solves the problem of sun angles. And with the flat, square, rectangle, whatever, non-circular flat Earth, you still have a ball sun surrounded by a bubble of lensing material, and it, in opposition to a half dome over the length of the Earth, creates this lens shape once again. So that's the only thing I can think of that works everywhere. The double concave lens. Don't care what Earth shape, what centrism, it works. So let me look at the chat again. I haven't been looking at it much. It's good to see everybody. I'm surprised anybody showed up because this was really spur of the moment. I just finished the drawing and said, you know what, the house is still quiet. People are going to come home in an hour or so, and I need to do this now. The sunspots have returned. Just a side note, they've been gone for about a week or so, and now they're back, and they are moving as predicted from my prior observations over the summer, like the hands of a clock. So hands that sometimes shorten and lengthen, but, you know, hands of the clock movement, clockwise. And it's nice this time. There's a string of dots of sunspots all in a row, and they're moving like the hour hand. So that's why I'm checking it every 2 hours, because 2 hours is a number on the face of a clock. Because the sun moves 15 degrees per hour, and that's it. The clock face has 12 hours, and 1/12 of the 360-degree circle is 30 degrees. So every 2 hours is 30 degrees of movement of the sun. So that's, it should be at the next hour on the clock face. So anyway, it doesn't move quite that fast, but that's the distance it will move. So anyway, let's see. All right, yeah, I'm hoping this series will answer some questions. It first of all says what's wrong, why there's a problem, why questions need answered, because movement of the sun as observed on the ground doesn't work in any current models that I'm aware of, with just one lens or no lens, with whatever angle they want the sun at, doesn't work. You have to have a double concave lens between the sun and the Earth somehow, no matter which shape. So that's the point I've been trying to work toward, and I can't think of anything else I need to say right now. Spread the word if you can. I would really like other flat earthers. I don't, you know, the ball earthers, if they could be nice and acknowledge the problems with their own model, that would be okay. But I would like to see why the double concave lensing effect doesn't add up. In other words, I want somebody to falsify the double concave lensing effect. Nicely, if you insult me or otherwise, you know, troll or get nasty, I don't even want to listen to you. I've had way too much of that. I'm tired of it. If we can't talk like adults, we can't talk. So there you go. That's all I've got. And watch the whole series if you can. But let's see, looking at the chat, sorry. Oh, okay. Yeah, I was wondering what you were talking about. Anyway, there you go. Apply it to any model, see if it doesn't help solve some things. And as I've said in the prior video, the angle of sunrise, sunset, and zenith at timeanddate.com seems to be accurate, at least in my location. I'm in the Northern Hemisphere. It seems to be accurate. So, as I said, my point was to show what's wrong with those sun paths that Time and Date agrees with and verifies in every model and what the solution might be. So this is the best I got, and I'm really probably not going to think about it for a while because I'm burned out. So, yep. All right, I'm going to shut down. Thanks everybody for coming. We'll see y'all later. And God bless everybody. Jesus is coming soon. Be ready. See you later.